A public health official claims that the mean home water use is 350 gallons a day. To verify this claim, a study of 20 randomly selected homes was instigated, with the result that the average daily water uses of these 20 homes were as follows. The mean and the standard deviation of the sample are 353.8 and 21.8478 respectively. A researcher is going to use a hypothesis testing for checking the above claim at 95% confidence level. Okay. Before we go to the questions, understand the information we have. Okay, here you see the mean and the standard deviation are given. Mean is the 353.8, standard deviation is the 21.8478, and also we have 20 data. Okay, so let me write down this information used in our notations. So mean of the sample, we write down x bar. Okay, then sample standard deviation, which is 21.8478, is the s, simple s. Then 20 over here, that is the sample size, n equal 20. And other important factor is this 95 confidence level. What is the 95 confidence level mean? That is the C. Okay. If C is 95, then alpha, which is significant level, that is we need point 0.05. 0.05. It means you know alpha equal 1 minus C. Okay. Now go to the part A. Write the null and alternative hypothesis. Okay, before we decide null and alternative hypothesis, we have to check the claim. What is the claim? The mean home water use is 350 gallons a day. Okay, that is our claim. Again, our claim is the mean home water use is 350 gallons a day. Therefore, our null hypothesis, which is H naught should be mu equal, this always equal here, 350. Then versus our alternative hypothesis, which is HA mu not equal 350. We need to check this claim is correct or incorrect. So this is the null and this is the alternative. Part B asking calculate the test statistics. Before we go with the test statistic, we have to check the given information. Why? Well, we use two test statistic T and Z. Okay, here we see we have sample standard deviation. Sample standard deviation is the x. Therefore, we should use T test. Why? Because sigma is unknown. Population variance is unknown, but we have sample variance. So what is the T naught? T naught equal x bar minus mu naught divided by S over root n. Okay, we know all the uh, information here. X bar equal 353.8. What is the mu naught? Mu naught is the mu value under h naught. Okay, under h naught is here 350. Therefore, it is 350 and divided by s is the sample standard deviation is 21.8478 and divided by sample size which is 20 and it's square root of this. So then this equal 0.7778. Well, that is our test statistic. Okay. Then they are asking give the two critical values t from the table. What are the p values for these two entries? Before we go to the table, we have to know the degrees of freedom of the t. Degrees of freedom of the t. What is the degrees of freedom? Always n minus 1. Okay. Therefore, here n equal 20. 20 minus 1 equal 19. So degrees of freedom is 19. Now we can check the t table. Okay, this is the t table. Okay, now as I told you before, our degrees of freedom is 19. It is here. And our t naught, which is test statistic, was 0.7778. Okay, now we are looking for this number in this row. Okay, you see we don't see the number 0.7778, but we see two numbers, one less than and one greater than, these two. Okay, these two are the these two are the critical values. Okay, because our 0.7778 should be in between this. Okay, now we know our HA, which is null alternative hypothesis, was mu not equal 350. Therefore, we know this is two-tailed test. Two-tailed test. Okay, now go to the bottom of the table and check the two-sided p-value. Two-sided p-value. This one. Okay, this row. Now check the corresponding p-values for these two numbers. And you see this one, these two numbers are the corresponding p-values for these two t-values. As I explained before, we saw two numbers point 688 and here point 861 and our test statistic should be somewhere over here. We have no idea, but in between this number 7778. Okay, so these two numbers are the two critical values, so you can say t1 star equal 0.688 and 2t star, so 2 t2 star equal 0.861. Now find the p values. Actually this p value according to our table 0.5 and this p value was 0.4. The p value of the test statistic should be greater than 0.4 and less than. Okay, now part D asking what can you tell about the claim. Okay, so we have to compare this p-value with alpha. Okay, alpha is the significant level, so alpha equal 0.05. It is the problem, it is given, so we know 0.05 should be somewhere here. Why? Let me explain over here. So our p-value, the point 4 and point 0.5. Okay, these are the range of the p-value. So alpha should be somewhere here, or use somewhere here. You see the p-value of the test statistic should be in between this. It means the this p-value should be somewhere here, then alpha less than zero point 0.4. Therefore definitely you can say alpha less than the p-value. Therefore we can say h naught is not rejected. H naught is not rejected. H naught is not rejected mean, so the claims that the mean home water use is 350 gallons a day is true. Again let me explain. H naught is not rejected mean this H naught, which is mu equal 350, is not rejected. It means that should be true. For our claim also water use is 350 gallons a day is true. Okay, then let me explain part E. So what is the part E? Give a 95% confidence interval for the mean in the population. Okay, again go to the information we have. We see we have the sample standard deviation, therefore we should use the t. So we, what is the t? X bar plus or minus t star time s over root 10. So this is the confidence interval for this problem. Okay, x bar, we know x bar already, 300 353.8 plus or minus, I will leave t star for a minute, but s point 21.8478 divided by root 20. Okay, T star. So how do we find the T star? Actually, I explained how to check the T table. But again, what is the degrees of freedom? 19. Okay, go to the 19 of the T table. And they are asking 95 at the top of the T table. Go to the 95% here. Actually, confidence level. See. Then you take the number over here, which is, this number should be 2.093. 2.093. So therefore this should be 2.093. Therefore our confidence interval, you can simplify this, should be 343.575 comma 364.025. So this is the confidence interval at 95% confidence level.